All right, everyone, welcome to our webinar, Introduction to Python Scripting in Coreform Cubit. We will be led today by our friend Norbert Hofbauer. In today's webinar, we're just going to go through a quick introduction. We'll talk about Coreform and about Hofbauer, and then we'll take you to live demonstrations. Most of this webinar is going to be live demos today, so you'll be able to see it in action. We're going to show how easily you can run Coreform Cubit inside a Python script, create a custom toolbar, easily create a mid-surface of a thin part using Python, and show you how to use Python to automate a simple convergence study. And then we'll have time at the end for Q&A. So Coreform was founded in 2014 to develop a next generation simulation software. We're located in the great state of Utah, where the weather is beautiful today. We have two software offerings here at Coreform. We have Coreform Cubit, which is, of course, what we're discussing today. We also have Coreform Flex, which is our next generation isogeometric analysis solution. If you'd like to learn more about either of those, you can visit our website, coreform.com, and you can request a free trial. Coreform Cubit is our mature software, and it's the commercial version of Sandia National Labs Cubit software. It's a general purpose meshing toolkit with a number of really useful features. There's CAD import and cleanup, there's semi-automated hex meshing, lots of tools for imprinting and merging and healing. Coreform Cubit gives you maximum control over your mesh properties and quality. And of course, Cubit has its own scripting language, which is very useful, but it also has a wonderful Python API. And that's what we're going to be discussing today, is how you can use that Python API and the benefits of Python to simplify some tasks, to automate repetitive tasks, and get maximum control over your own Cubit experience. We also offer flexible licensing. If you are interested in Coreform Cubit or have any questions, you can reach us at sales@coreform.com. If you go to our documentation page, this is what it looks like, and you can see we have a lot of resources available for you. We have a help forum that's very active. It's a great place to ask questions if you have a meshing problem. We have tutorials and training materials. We have video versions and PDF versions if you'd like to walk through things step by step, including some of the information you're going to learn about Python today is available in our training materials. I also recommend, if you haven't already, that you check out our YouTube channel. That's where we'll post all of our webinars. We also have a number of, absolute basic getting started videos, as well as advanced hex meshing techniques, and also some specific use cases like neutronics and geomechanics and things like that. Okay, with all that out of the way, I'd like to introduce our host for today, Norbert Hofbauer. He is a Coreform Cubit expert and also the CEO of Hofbauer Maschinenbau, which is an engineering office based in Austria. So they provide all kinds of engineering services, and they're also Coreform Cubit resellers over all of Germany and Austria. You may know Norbert if you have interacted with our forum. He's very active there, helping solve problems and provide support for our users.
Okay, the first thing is what I want to show is our resources that we have, because you can find the methods for the Python API in our documentation. Just want to point out that if you're new to Qubit, please take a look at the training slides that we have. Those basically gets you started with Qubit and just shows a lot of features. Usually it takes like 2 days, but then you know how Qubit really works and how the workflow is. The other thing that we are going to use today is the user manual. It's pretty large. if you want to take a look step by step, what I want to show is where you can find the Python API, the documentation about it. Because if you script something with Qubit, with Python, you will need that. I just want to show how you can use Python within Qubit. In the command line, you can switch between Qubit commands and Python when you press the button or when you're typing Qubit or Python a command. So we will just create a brick, mesh this, and then I want to export it. Of my webinar folder. So now I've made 3 comments in Qubit, and we can already make a Python script out of those that we can call within a general Python script. Where do I have my folder here? What we would need to add is a input path for a Python script. So we would need the input sys module. We then can append the path to Qubit. Then we could already import Qubit into an existing Python script. And those 3 comments were the comments that I executed in Qubit before. If we want to run this script now in Python, you could just open PowerShell and execute this Python script. So we just opened Qubit, executed the comments from the journal, and after the script is done, Qubit will close. And that's how you basically import Qubit into an existing Python workflow. I think that's pretty handy. The next thing I want to show you is how we can create a custom toolbar and place a script onto a button to do some repetitive tasks. Just going to show you what I want to do here. On this geometry, I want to more or less see which type of surface we are looking at. So I want to color the different surface types, like the cylindrical and the planes. Do we have a spline somewhere? Nope, but it's at least another one. So again, so what we need or what we want is to use the surface class that we got access through the Python API. Make an object for a surface and check if the surface is a plane type or cylindrical type or something else. So in Qubit, you can basically select entities also via the command line. Now I selected all surfaces, and here I got an ID list of all surface IDs, which I could copy paste. Basically, I can access this list through Python. Qubit is the object that we need with all Python API methods. We can then parse the Qubit list. What's pretty handy, we could even use F strings here if we want to. And this will also give me the same IDs that we can get through a normal GUI selection. So Just going to copy paste. Oh, wrong button. We will then just need to assign an object for the IDs, work on that. Then we can already start building a loop so that we can loop over all IDs. To get access to the surface object from our Python API, you just need to, again, use Cubit or a whole Cubit object, call the class, and on initializing the class, we have to give it an ID. So now we got access to the surface and to all methods that's behind them. Now we can query the different surface types. And again, we can execute and comment in Qt using an S string. So we want to color, or in this case, draw surface with the current ID. That's why you're using the S string. Let's say with a color green, and we want to add that. Because if we don't use the add keyword here, we will just draw this single surface and no other geometric entity. So we won't see anything, just a single surface. We can do the same again for the cylindrical type. Just have to look up the wording is cylindrical, okay. I'll just assign a different color. And the last check can be if it's of a different type of surface. So that's all we need to color the geometry. Are we in the history? Yeah. And that's pretty useful to just get the idea of what you're facing when you're trying to mesh or web cutting this down. So we could either rerun the journal every time, which is, yeah, doesn't make really any fun to search for a script or a journal and press the play button again, or always doing a copy paste. That's pretty boring. But we can use this existing script and make a button for it. For this, we can go to the top menu. Under Tools, we can find the custom toolbar editor. We can then add a new toolbar. Let's call it coloring. We can choose a saving location. Yeah, we'll just overwrite this one. Then we already got the toolbar here on the right side. The next thing we could do is adding a button. We need to choose to add a Python script button. If you have an icon, you can just get your custom icon here. Just name it surface coloring. Then we can assign a script to it. And press OK. Now we got here our own custom toolbar. Now if I press the button, I can run the script that's behind the button. And you could do that if you have some geometry modifications too, it doesn't really matter as long as you point to the script. We've got basically interfaces for the geometric entities and our Qubit interface, which is the most generally useful. There are a lot of methods. I don't want to show everything, that would be too much. Today I want to show basically the surface class, and we are going to use a method called closest point trimmed based on a location, and that checks if a surface is a cylindrical or plane surface. Is on a thin geometry. That's basically a sheet metal part. And if I want to get not a hex element mesh for this, but a shell element mesh, I would need to mid-surface this geometry. Usually when it's a simple geometry, I could just say, okay, create mid-surface, get me some pairs. I don't have a single pair, so I would probably just select top surfaces, make a composite, select the bottom surfaces, again, making a composite. And then I could just choose the surface pair and say, okay, please, you would make me a mid-surface here. And I will run into an error. Because when I then would look up in the documentation why it is failing, I could here search for my keyword that I wanted to use. Reducing thin volumes. And here I would find my explanation why this doesn't work on this type of part. So now I got an option like, okay, I don't need the exact mid surface. I could just copy the top or the bottom, mesh this and use that as shell. But that's probably not always really usable. So for this, we could also make use of the Python API. Basically, what's happening here would be I would import my part. I would then create my composite surfaces, and I would copy one of those and already mesh it. Okay, here we go. So what I have done here is I copied the top surface. So I now got my sheet body here. I united all surfaces and meshed it. And the thing I want to use is in the Python API for the surface object, there is a method called closest point trimmed. Get the nearest point on a surface to a point that I specify. So what I want to do is I want to use a node. Just going to highlight them a little bit. I want to use the location of a node and execute the closest point trimmed onto the top surface, which had made that composite, and the bottom surface. Then I will calculate or compute the midpoint between those surfaces, and then I want to move the node right into the mid of those two surfaces. I've got here two methods. The first one is that I get my vector, my moving vector, right into the middle. And the second one is to actually move the node. And that's basically a pretty short script, but it does the thing that I want to know or I want to do. Just takes a short of time. And we are already finished. If I now take a look at the mesh and I select my sheet body, now I moved all my elements right into the middle and I have a mid-surface mesh that I can use for my simulation. There is, of course, as we are using here a Python API, we can get an interaction between your solver and the results if you've got access through Python onto the results or directly in your solver, and more or less make an, let's say, automated workflow. Just to show you what I have in mind, I'm going to use an open source solver called Calculix. It's a free Qubit plugin that you can get over GitHub. It's a solid mechanics solver for linear and nonlinear solid mechanic problems. To get it working in Qubit, you basically would just need to download the binaries, unpack the zip file, and point Qubit onto this directory. The only thing that you would need to do after that is to restart Qubit. And now you added a custom plugin to Qubit. Here it states Qubit with Calculix. We now got added a new model tree and some widgets in the navigation panel. So what I want to show you first is a simple convergence study. In this repository or the Qubit plugin that you download, there are also some example files, like here, a short script how to get the convergence study done. Just going to copy paste right before it runs a job. So I can copy paste journal, just paste it in and it runs. That's basically a beam that's fixed on the left, and on the right I push it down. And what I want to do is I want to start with a very, that's not a very coarse mesh here. Okay, haven't set the, wasn't, hopefully that's it. Yeah, I want to start with a very coarse mesh. I want to run a job, check the value here from the results, and refine the mesh, or in this case, I will delete the mesh and mesh it again with a finer element size. Then the job will run again, and it will then compare the value from the first run with the value from the second run for the for mesostresses. For this, the plugin got an Python API. Instead of Qubit, it now is CCX with a custom Python method. I can use the Qubit API to get my closest node near a location in space. That's 0, 0.1, 0.1. So it's basically this note that we will always ask Qubit. So if I remesh, it will always get the closest node to this location so that I have a value to compare. If the value is not within my error range that are specified on top, it will rerun until more or less I get convergence. So when the last value and the value before are matching within an error range. Get that a little bit thinner. Just to get a better overview. Just zoom out a little and rerun the whole script. So now it's matching, it's running a job with all boundary conditions and loads before, and runs until my condition that I set is reached. And after that, I can plot with Python directly what happens here. So that was the coarsest mesh, that was the first mesh, so the difference was too great, so it took another run. Then I get the more accurate result, and so on, and probably the 7th iteration would be fine enough. And as down here, I plotted all my values. I can see how the value changes with a finer mesh. So I could say, yes, 7th iteration was fine enough. I could then take a look at the results. How this mesh looked. Yeah, you could basically do that as long as you have access to results or any other, let's say, condition that you are using just to remesh something. I don't know if you use any optimizing algorithms, but it's how you could basically do a simple automated workflow. The other thing that I want to show is that if you have access to your results, you could even try to make a refinement based on those results. Basically, just copy paste here again. Yeah, that's the best thing about Qubit. You can't get lost. You don't lose any progress when you more or less, make an error in your meshing or a model setup process. You can just take over the step back. It's wonderful. So we got here the same problem again, like before. Fixed on the side, pushed down on the other. What I want to do here is I want to run the simulation. I want to check which, in this case, I want to check if the integration point results from my element have too much difference between. So like here I state it's like, okay, if von Mises stress on one integration point is greater or less than on the other side of the element on another integration point, I say, okay, give me this element, put that in the list, and after that I will refine all elements that are not accurate enough based on my condition here. So how will this look? That's the first refinement based on results. And that was the second. So here we are accurate enough, here not. So I took a second refinement step. Okay, that's the smoothing operation. Yeah, you can do something like that with the Python API if you have access to your solver in a way, or you can read in your results, even if they are written as CSV, because with Python, you can read also that in. The last thing I want to show is Qubit is not just about basically, remeshing something or setting the element size. We also got geometry modification tools. That. I'll just again copy paste here my short setup. Basically, it's a plate with a hole in it. And let's say I want to modify the diameter or the radius from this hole. I could do that with Qubit. I can tweak this geometry. I can make a little offset here for this surface, like 0.3. Can preview it. Okay, that was too large. And change the geometry right before I mesh it or do anything else. We can, of course, also get that functionality through the Qubit comment that we got in the Python interface, again in the script. So what we got here, it's a plate. We fix it on one side, we put it under tensor. We will then create the job and analyze it. We can again ask for the closest node on a specific location that we defined earlier and check, like here, for example, if the value on that node is under a value that I want, or that I say, okay, the material can withstand 200 megapascal. Again, we can do a while loop until, the diameter is big enough. And we then say, okay, we've optimized that as hard as we could. Or we just break after a few iterations. Again, I'm putting the radius values here in a list so that I can view that later, how the radius changes over the value from the node or the von Mises stresses. So that was from the last. So that's how basically that's the radius, not iteration. That's the radius that changes until our value got reached. Yes, that's how you could automate something like this. So if you have some optimization algorithms that's changing more geometry or just geometry in a specific location, you could utilize our the geometry modification tools from Qubit. You can get them into a Python script. Where do I have it? Tweak surface. It's already here because through the Python API and with the F strings, you basically can access every feature that Qubit have through a Python script. And that's pretty handy.
Thanks, Kim. We do have one question that I thought would be good to answer live. There was a question about, Norbert, if you go to the surface class documentation, whether or not there is a method for directly coloring the entity, and there is. If there is a set color. If you click in there, I want to explain, one of the things you'll see is, this method's description looks like it looks like a C or a C++ function, right? With returning a void, and it takes in a standard array of doubles. And The way that we generate our Python API is through a technology called Swig, which essentially converts C or C++ into Python accessible methods. What we recommend is a lot of these options that directly modify objects. Those objects are the underlying memory, essentially, of the geometry kernel. And Python doesn't do a great job of modifying those kind of C or C++ held entities. So we don't necessarily recommend that you use direct methods that modify or create entities. Instead, we recommend using that CMD method from Qubit, which essentially then issues a Qubit command. And that's just a much more robust method for creating and modifying entities. And that's why Norbert used the Qubit CMD with the draw command that set the color. So there are those methods, and those methods are available. And many power users will use those, but we recommend for general purpose consumption that you use the CMD method instead.
If I remember correctly, there should be a color table somewhere.
Yeah, and that is the other issue with that as well, is that it takes in, that they
So you
provide an
could,
example of 0, which is the colors.
you
And
could of course just use the CMD type
Mhm.
with an F string, put the coloring that you want or like in the list. Yeah. And just instead of, you call the list, you call the pointer to like the position 15 in the list,
Mhm.
and then it will just insert Corel.
Yep.
Would also work.
Yep. And then there's another question as well. It
Yeah.
was kind of around that parse qubit list. Maybe Norbert, let's discuss F strings briefly. This question
Yeah.
essentially comes down to the second.
Ah,
So the full question here is that he wants to be able to use parse qubit list, and he wants to say list all of this or get all the surfaces that are in volume 1. Or in volume, and he has a variable, say, substrate vol ID that contains an integer. So how does he pass in that integer into that parse qubit list?
yeah,
And
we
we
can just do it.
Yep, and we kind of glossed over a little bit, or didn't gloss over, but we mentioned or introduced F strings, where the F is short for formatted. So it's a formatted string, and that is a Python functionality. So what Norbert's doing here is if he takes a string and he
So,
puts it, and
oh,
yep,
I
if
will
you,
just show what's
yeah,
hard-coded here, and then we will insert the
yep,
F string. So now we got all surfaces from volume 1, of course, but we just need to put an F before the string that we want to be formatted. We need to use this bracket, and yeah, I will just hit ID2 because then nothing should happen. The list should return nothing. Yep. I would then just use ID here. Yep, that's better. Now we got an empty list, and if I take it the one I have, I think that was the question, yeah.
yes, that is exactly the question. So if you are curious to learn more about that functionality, I recommend that you look up F strings in Python documentation. But that is how you can insert those variables into these commands.
Yeah, and of course, if you run into troubles or have any questions, yeah, just use the forum or our support mail. I would really like to answer your questions.
And there is one other command that I think is useful, Norbert, to show, which is the get ID string. So oftentimes you might have, say, a list of IDs, and you want Qubit to insert the IDs into a command. So in this case, where you've gotten these surfaces, you could draw all those surfaces, say, with a qubit.getID string with a list of IDs. And that's another useful little command that's similar to the previous question.
Get
Yep.
ID string. This one.
Yep. So in this case, if your ID was a list, this get ID string will convert that list into a string that's parsable by qubit. And that's the other case where instead of it being a single integer, if it's a list of integers.
Mm.
And then we have another
Just
question.
yeah.
Oh, we have another question. Well, let's maybe finish off this line of thought. So if we make an entity with qubit CMD, is there a pattern for getting the Python entity to query? And there is a method that is called get last. I think it's get last ID or it's
Yeah, it's
last
get
ID.
less. It's get less that I think.
Yeah. So could you show that maybe, Norbert, of creating a brick and then getting the volume ID of that brick?
Yep. Um, just reset. Ah. If I create some more bricks. Ah.
Yep.
Yeah.
And so you can see there it's printing out that number 5 as being the last volume that was created. So, yep, that's how, if you'd created some entity, again, with a qubit CMD or regular qubit command, then you could grab what that entity is. And that works for the volume, surfaces, curves, vertices, so forth. Okay, and then the other question is from Kirill, that he's working with surfaces that are defined in .dat files in an XYZ format. So it looks like a CSV type of format. And he wants to know if he can import those DAT files directly and create a surface based on those point coordinates. And I think certainly importing the .dat file is as simple as using Python to read that .dat file.
I think there must be some examples for something like this also in the forum. Just think a few days ago there was here a question if you could open from a CSV file and get point data into Qubit. That's of course possible. But it's just for creating vertices here. I don't know how really the that file data is. If you, I know that at some point you could create surfaces based on if you're more or less doing a net surface, so you got data from points where first to a spline, then getting those curves, and then creating a net surface. That's possible. Greg. It's hard to just say it's extremely general, but it is possible based on the data.
Yep. Yeah, I think you're the person who's going to know best, Kirill, how your data is structured. And so if you have some structure to your data, such as maybe you have lines of equal X values, and from that you can start to say, I know my data is organized, or maybe I can do a sort and I can create spline curves of kind of equal X values, and then I can connect adjacent curves, in the Y direction to start to create those. The general solution, or the general answer is that if you can define it in your, if you can define an algorithm for reconstructing like how you would build those together in Python, it's likely possible in Cubit. We provide a large variety of functionality for creating geometry. And it looks like he mentions it's in a regular grid. So
Yeah.
yeah, I think
Then
we could probably provide an example. I think we even have an example somewhere in our form that we can provide in a
I'm
response.
sure there is a forum example, but to find it,
Yeah, we'll
I have a
include it in
picture in
our,
mind. Yeah,
yeah, I
we
think
will search it later.
yeah, we'll include it in our response or our reach out email to everyone, this forum post if we can't find it right now. So
Yeah, I will search it later.
mhm. All right. It looks like I'm not seeing any other questions in our Q&A log. Oh, maybe one just came in from David. Um, he wants to utilize the mid-surface for thin housing with sharp features so that continuous does not expand beyond. Is there a method to quickly select the external and internal surfaces?
Um, mm, I don't think that there is really a direct method, but I know that a year ago I scripted a Python method that I laid onto a button that does exactly that, because you where do I have don't know the right method that you can't change the angle, the searching angle for the continuous surface. That's possible.
Yep.
I I know where to find the script. I will should search it. But yes,
Yep.
it is possible.
Yep. So we'll look for that method as well and include that as well in our follow-up.
Thank
And
you
I will.
for your hard work, Norbert. That was fantastic. Thank you, Greg, for your support. And thank all of you who attended. You can use this QR code to learn more about Coreform Cubit and request a free trial. Thanks a lot. Hope everybody has a great day, and we'll see you at the next one.